Hello guys, I think we are live. If I've set this up correctly, we should be live anyway. Let me just check that it's all working here. I think you can see the excavator there. It's a good start. Let me just check that all is working. Yeah, sounds like all's working there. I can hear me tapping on the mouse and tapping on the keyboard and the thing. Let me just announce on Facebook that we are up and running, and we'll get into the video. Okay, I think that's all running as we would expect. I don't know if the little announcement thing, I posted it as an event, but I don't think it actually worked that way. But anyway, we are live. Did anyone get a notification of that? I'm not 100% sure. So the plan today, let me just move my mic back over here. The plan today is to take a look at this little power module. We did it before with or for IC Station. They sent this in and we did the kind of review. So what I wanted to do, it was actually someone asked the question under that video, could we power the excavator from that module? So what I'm going to do today is just see if we can power it from that module, because at the minute I use these 3 batteries. I just wire them up into either what would it be, 7.2 or 11.1 volts I think it is, and well, basically it'd be much handier if I could just use one of these batteries, so I could keep the other 2 charged all the time and just rely on the little power module, since we do have quite a bit of space in here. But I don't know if I'll actually use it that way or not. We have to see how well it works. So let's see now. What we'll do first of all is just see at what voltage the excavator starts to work. So the way I have this battery set up, I have individual connectors. So if we give it some power here, we are at 4.2 volts and we have no control. If you can see up there, the little signal bar is not right. So well, when it's a little dot like that, it means we've no signal, and when it's kind of full up, I'll show you now in a second. I think with 7.2 volts or with 2 batteries. Let me see now. Just to hook this up. So all I'm doing is connecting these batteries in series, give me a higher voltage. Actually, it'd be more than 7.2 volts because the batteries are fully charged. It'd probably be 8.4 maybe. So there we go, 8.33, and immediately our radio is connected. So we should have control here. So that's working as you would expect, and I'm pretty sure we can take it up to another battery. Well, fingers crossed it works with another battery, or this could be a very short stream if I blow the board here, but I'm pretty sure I had it working with the 3rd battery before. So let me just check it out. around 4.2 volts onto this, bring us up to around 12 volts, I think. So and there we go, we have signal again, you can see there. And you can see there with the extra 4 volts, the motors are much faster, because that's because the voltage on the motor drivers is, well, the motor voltage on the motor driver is directly connected to the batteries here. So if we up the voltage of the batteries, we're gonna up the voltage for the motors. The NRF and the Atmega chip that's driving it all, that is all running on a 3.3 volt regulator. So everything else is running at 3.3 volts except the power for the batteries. So if we flick back to 3.7, just one single battery for this test, and we'll see if our power module can actually step us up to the voltage we want. So we will monitor the output here with the oscilloscope, because then we'll see the ripples. Well, I'm assuming there's going to be ripples as the motor is starting up, or if it, I suppose if there's a bit of resistance on my my little drive mechanism, so my 3.3 volt mechanism, or my M3 drive shafts, or whatever you'd call them, linear actuators, if there's a bit of resistance on them, it will probably cause the motors to kind of spike and oscillate, and I think that's going to have an effect on this little module. So the only way to find it out is to have a look and see what happens on the oscilloscope. So all I'm doing is connecting the output of the little module here to the board the same way I had it connected before, and instead of the multimeter this time we have it hooked up to the oscilloscope. So I'll hook up the multimeter to the battery voltage, so you'll be able to see that we do have the 4.2 or 4.1, whatever the voltage the battery's at the minute. So you'll be able to see that. Let me just this battery up. I'm only using one of the batteries here, only one battery I'm going to connect, so we should be just at the 4.1. Okay, so we have 4.16 there, and our oscilloscope is saying we are at 3.92 volts, so we're actually restricting the voltage to the Komatsu at the minute, and as you'd expect, we have no signal. So let's start to wind up the motor driver, or the step up converter here. You'll see it change on the oscilloscope there. You should, if I'm screwing it the right way. Yep, here we go, it's starting to climb now. There's 4.25. There at 4.5 we got a signal. Let me just back it off now to see where we actually get the signal. Okay, so we're losing. Tell you what, you can't really see that, but I'll turn it up anyway, and you might be able to see where it comes on. There's 4.5 there. I guess it turned on because the battery voltage just dropped. Yeah, so around about 4.5 volts it seems to be where the motor or the control board kicks in. So I guess that means that at the 4.56, our regulator must be getting us up to probably 2.7 or 3 volts, I guess. I'm not sure exactly what I'd be regulating it to. I could probably measure it there, but for this I don't think I will. It'll be a little bit tricky. I'd have to move a lot of stuff around here to get that wired up. Okay, so this looks to be the minimum voltage that we can drive our little excavator at here. So when I try to move the motors, it would probably cause the little board to reset. So let's just see what happens. It's actually perfect. It's obviously slow because we're operating with a very low voltage, but other than obvious draw on the current there, we're seeing no huge oscillation on our output signal here at all. Maybe I wonder if I increase the time. No, not really seeing any kind of fluctuation at all from it there. So I guess that means that our little step-up converter is pretty stable down at the low voltages there. So if we put it up to around about what 2 batteries will be, around about 8 volts. Let's just wrong way up to we're up over 5 volts there. And if what do I need to do? Volts per division. That's telling me I'm at 6.74 volts. Okay, we're up at 6.74 volts. I'll keep going. So there's around about 8.9 we're at the minute. Go down a little bit just. Okay. So at the minute we're at about 7.4 and we look to have pretty stable voltage. Let's not really seeing any fluctuation on our signal again, so we're still pretty strong. Let's try the can you see that on the screen? So this motor will obviously draw the most current because it's under the most load. This arm is extremely heavy, so the whole arm is die cast, so trying to move it causes a lot of fluctuation. So if you watch the screen there again, you'll see a little spike there. You can see that. How can I zoom that in maybe? Back in here, wrong way, and shift it. Zoom in again. Oh, which way am I going? Right. And I'll increase the time so it's a little bit faster. Okay, so you can surely see that on the camera. Maybe I'll go again. It's still a little difficult to see on the screen. Oh, that's as much as I can go. I have to go back. Now, where is my signal gone? Ah, there it is. Okay, so you can kind of see that spike there. That's the motor starting up. I bet we can make that a little bit worse if we Yeah, look at all that noise now. There's a lot of noise. But if I put the boom out to its most here, and then we start the motor, you can see that huge spike there as the motor starts off. That's just a huge load that the motor is putting on the circuit. Wonder, are we seeing any drop on our other voltage there? Yeah. So because it's drawing so much current, it's causing the voltage to drop over there, because the internal resistance of the battery is going to cause the voltage to drop. So you can see that this motor is under a lot of power there. Maybe I'll measure the current there if I can, just to see what are we actually drawing. So let's get this fella, and we'll hook him up here if I can. I know how to do it. I'll catch it over here on this signal. What amps am I at there? I'll go for the 10 amp max just to be on the safe side. And in around there. Now let's see what we have. We have connection, that's a good start. So you can see we're around 320 milliamps to lift the boom. So it doesn't sound like a lot, but when you're only looking at small little electronics, it's quite a lot relative to what the microchips would be using. Let me see. You know, when you start driving a few motors at once, you know, there's a half an amp we're drawing there. No, 500 milliamps is quite a lot. You can see it impacting there, but our little step up converter there is hanging in there pretty well. It seems to be having very little difficulty supplying this power and supplying it stably. So maybe we'll try it a little bit higher. We'll go for around the 12 volts maybe, and see if that makes it any worse, because as we go higher voltage, we are probably going to draw a bit more current as our motors are going that little bit faster. Let's see which way. Other way. Okay, to drop this again. And up another bit. Only up about 10 volts now. We'll keep her going until we get to around about 12 volts, where we would have around about to 12 volts, that would match the batteries close enough to the 3 batteries. So we're at 9 there. Let's shoot it on up. There's 11.1. That would be the 3 batteries discharged there at 11.1. So, whoa, that was a big spike there. Did you see that? So it's obviously taking a huge amount of power. So that dropped. Let me see, I'll have to zoom out actually to see that. So, see, that's 1 volt per division there. If I put it up here, let's try and see. So that was, where did that go? A little bit there, so that's that 4 volts that dropped there in that spike? It's quite a drop. If your voltage regulators couldn't handle that, you'd end up with your control board resetting, and you might find that you might think that there was something wrong with your code, but it was actually the controller resetting over and over again, or the control board resetting over and over again, because that's the kind of thing that can happen on, say if you're making a robot and you had heavy drive motors, or big drive motors, and the robot's heavy. You could get a big spike like that continually, causing your robot to reset all the time, and you might think that you've just made a mistake in your code, but it can be something as simple as that voltage drop there. So that's the main motor. The other motors that aren't under so much load, they aren't causing such big spikes, but still they are causing substantial enough spikes, and you can see even the voltage is going up there. That's the effect that the motor is having on it. Let's see now. I'll put up the voltage to up to the 12 volts anyway till we continue with our little experiment here. There's 12.6. Wow. That drop is down around a bit there. 1, 2, 3, 4, 5. That's like a 5 volt drop there. So I don't know whether it's starting to reach the limits of what our little step up converter can do, but that is a substantial spike. And then there's a huge amount of noise on the power there. Oh, did we just lose all? What happened? We've lost power, but I don't know why. Did one of those voltage spikes just kill our circuit here? We don't appear to have anything very hot here, so I don't know why it would have stopped. Oh. Okay, well I don't know what happened there. It's like our power module turned itself off. I'm not really sure why it would have done that. Maybe all this noise is kind of getting back in. Let me see, where's the output division if I back out a bit more. Like that's nearly a 2 volt drop in the unloaded motors there. Nearly 4 volts there. It's when we try to drive the main motor, it seems to be causing our little thing here to cut out. I wonder, this isn't a smart thing, is it? No, there's no chip on this, unless the little module itself is somehow doing it. But it looks like trying to drive that main motor is causing us to cut out. I wonder if we started slowly. So if you start the motor slowly, you're able to get it to but if we just try to oh no, now it's working. How strange is that? You can see all the oscillations there. I don't have the weight block on the back here, so it's kind of a bit all over the place. Yeah, for some reason that's able to knock out the motor driver, or the little step up converter. It's a bit strange. So there's a lot of noise on that signal. I don't know if it's really to do with this. I suppose we should have a look whether it was that noisy with the 3 batteries in tow. So let's just check that out for a second. Let me see. I'm going to wire this one. Okay, I think I know. I just need to hook up the battery here and we'll test that out. Red, black. Try not to wire my batteries the wrong way. I could end up with a fire here very easily. So, right, here we go. Okay, so we are up at 12.3 volts there. Let's give it a go. Oh, let's see. There seems to be much less noise there when we're driving it directly from the batteries. So before we were getting from that motor, I think we were getting 2 or 3 volts drop. That one was nearly 4 volts drop. Now it's around about 1 volt, I suppose. That's what that is. Let's see what this one does. Yeah, that one's not even dropping 2 volts. That was dropping, was it nearly 5 volts a minute ago with through the step-up converter. So although there is a lot more noise, or although there is still quite a lot of noise, it's not as severe as it is through the step-up converter there. And we don't seem to be cutting out. Well, I think it was the step-up driver or converter thing that was somehow cutting out. I'm not exactly sure how, but I think that's what was happening there. It doesn't seem like we're able to get it to cut off driving it directly from the battery. Oh, we have lost our feed here. Are we back? I think we're back. We're back on my screen. Ah yeah, there we go. Okay. We're back again. The camera decided to turn itself off for whatever reason. Okay, so driving it directly from the battery, we don't get anywhere near as much noise. I wonder what voltage this will actually go up to. How high can you drive an LM 1117 3.3? Let me just check and we'll see. I'm sure we can go pretty high with that. We could probably go to about 30 volts with it maybe, I'm not entirely sure. Okay, it looks like we can go up to 20 volts, so why don't we try that? I'm not particularly bothered if we blow the board, because I'm going to be replacing this board anyway. I don't have all the chips on it, and I want to do it with little header connectors so that I can unplug the board and plug in different things. If I change it later on, I can just unplug the board. So let's up the voltage on this for the crack and see what happens. The only thing we can damage on this is the control board and the 3.3 volt SMD NRF 24L01. So I'm not particularly bothered. It's not going to be a huge expense, and it'll be kind of interesting to see what voltage and what kind of signals we're going to be getting at that stage. So let us try this again. I need to hook this up to ground. That's it. Is it? Are we back? Yes, we're back in control. So we are at 12 volts there. Let's up it to 15. It's also interesting to see how fast the motors are when you have this high a voltage. Maybe it won't even go that high, I don't know. Right, there's 16 volts and we still have signal. We haven't killed it yet. That's all. It's very fast now. I have no limit switches on this model, so I have to be very careful not to reach the end of the threaded bar there, or just just break it off. If it would twist it off at 7 volts, it'll definitely do it at 16. We lost again there. So now we're getting to the point where the unloaded motors are able to cut out the excavator. So let's try it again. Okay, let's have a look at the main motor. Whoa, look at that noise on that line. Can you see that on the screen? That's like it immediately drops about 2 volts, and then it's got like a sine wave around 2 volts, and it's knocked out again. That would be pretty annoying if you were driving this the whole time, but you probably wouldn't be driving it this high. You'd be probably staying at the 7-8 volts maybe. I'm not sure. That's huge oscillation. It seems to have a harder time putting the boom down than it does raising it, which is a bit strange. I wonder what's happening now. Our motor seems to be locking up the whole time. So we seem to have a frequency about 7 hertz there. Whatever is the cause of that, I'm not sure. But I thought maybe it was the oscillations of this rocking back and forward, just taking a little bit of load off the boom each time. But let's have a look. If I put it back down, if I can get it to go back down. Oh, it does not want to do it. That's very irritating. Come on, work for us. No, it's dead. Okay, here we go. I just wonder if I hold the back of the excavator, will the oscillations reduce a little? Maybe it's not even going to start up at all. It's just not working for us now. Oh, maybe the battery's going as well. Hold on, I'll change battery. Oh, that's not right. That way. Okay. It really does not want to work at 16 volts. And that's not the control board, it's the step up driver thing. Okay, so it looks like we've lost control of lifting the boom anyway. Doesn't seem to be able to do that when you get up this high a voltage. Now it's not doing anything really. So it looks like the noise, or there's some load here. Nothing here is terribly hot. So it's a little bit surprising that it's working. I don't think we're drawing a huge amount of current, are we? 130 milliamps, it's hardly a huge amount of current. Let's up it to 20 volts for the crack anyway, see what it's like then. We should be able to get the 2 motors driving anyway. Have we killed it? No, it's still alive. I'm going to have to readjust our signal here. What are we at? 18. It's 20 there, I'd say. A little bit more. So we're at around 20 volts. Our regulator's not even hot, which is kind of strange, but I suppose it's not really driving anything, only the NRF and the Atmega chip, so it's probably not that surprising that it's not hugely hot. And now we seem to have no control at all. I have no speed control on this. Or do I? Oh, I do. I have speed control on the upper arm. Wow, that's a lot of noise. Looks like when you try to drive it too much, too fast, it just cuts out. When you're up at full speed, there's not so much noise anymore. But if you try to push it too hard or too fast, too hard, too fast, it cuts out the little stepper driver. So it's just not fit to drive it. Well, I suppose we are kind of driving it at crazy voltages, so it's not that surprising that it struggles with it. But at the same time, it's a little bit disappointing performance, I suppose. Have we killed it this time? Doesn't seem to be coming back to life again. See, we are back. The motors are extremely fast now. But there's no way we are driving the main boom raising and lowering motor there. Not a hope. Now I wonder if we hook up the 3 batteries and put that into the input of the motor driver, will we get much more stable performance at 20 volts? So I think that's what I'll have a look at next. Let me just check your comments here. A few comments there. Hello to the various viewers who commented there. Let me just hook up the batteries again. We'll go for the 12 volt input into our motor driver and see how that works for us. Or not our motor driver, our step up converter. So I'll have to unhook that from the excavator for a second, and we'll just get the voltage roughly right before I hook it up. I don't want to hook up to the control board at like 30 volts or something and just blow it all. Well, it'll probably be way more than 30. So what am I measuring voltage with here? It's this, isn't it? Let me hook this off and we'll hook this thing up. Hopefully it'll not just explode. Oh yes, I forgot. In the video we did for this, we seen that up in the input voltage, it didn't change the output voltage. I'd forgotten about that. That's a good feature. So I'll back it back to 12 volts. Well, 13, 14, that's around about where it would be if it was the 3 batteries, I suppose. So let's do that first. It was much more stable with the 3 batteries last time. So we have power here. Let's see what we get. I think that's less noise than we had before. That's closer to the level of noise we had when we were hooking directly to the batteries, I think. Which probably isn't a surprise. If anything, we're probably stepping down the voltage at this stage. So that's not too impressive. Let's up the voltage again. We'll go back up to straight to the 20 and see what it looks like. 19. There is 20. A little bit over 20. Okay. So this was kind of cutting out on us before. Let's see what's going to happen now. Oh, we've way less noise now. So if you wanted to drive your motors at 20 volts, an 11.1 volt LiPo battery, and that motor driver looks like a brilliant way to do it. There is noise, but it's nowhere near as bad as it was before. That's really good. Oh, that wasn't what I meant to do. I didn't even know that was connected. At least we know our slewing motor works. Which console does what here? Man, that is way too fast. That's all I wanted to do. That has crazy power now. Way more than we were getting before. And it's not cutting out, which is one thing. Our current isn't even crazy. Ah, well, okay, we weren't loaded. So there's a spike there as the motor starts, alright. You can see it there. But when it actually levels out, the noise isn't nearly as bad. So I would say that's pretty good. Oh, I keep hitting the wrong button. Let me see. Man, that motor is way too fast. We do have a bit of speed control, which isn't too bad. Let's see. Our regulator's not too hot, so maybe we'll up the voltage another little bit and see what happens. What will happen at 25 volts, for example? I'm assuming at some point we're going to blow something in the control board, but I don't know when that's going to be. Put this down. Oh, we have killed something. We have let the magic smoke out. What died? Was it the regulator? Did anyone see where the smoke came from? Oh, it looks like it was our crystal. Ah no, that couldn't have been like that. No, I must have blown something else. Funny, nothing is actually hot. Oh, I blew the motor driver. One of them there is hot. There's a little dot on that. I must have blown that. That was interesting. So, what were we at there? 25 volts or something when we blew it? So good. I wonder if I zoom in here, we'll get a look at what we have. I'm gonna power up. I think it's completely dead, although I bet the motor driver is shorting it out. What's the current looking like? Where is... It won't give me the current. How am I going to do this now? That's hooked up. Ah, yeah, right. So let's see. If you watch up there, if it's a dead short in one of the motor drivers, we should see it. No, we don't. Oh. Well, looks like we blew it and now it's fine again. Just temporarily blown. Did I imagine that smoke? I'm pretty sure I seen smoke. I'm pretty sure something blew there. Well, it wasn't any of the motor drivers. We have all... no. I blew one channel of the motor driver. Did I? Looks like I blew the channel of the motor driver that controls this motor. That's weird because I thought it was this motor. I thought it was the other motor driver that I seen the smoke come from. Oh, let me see. Well, that motor's definitely dead, and I can't see any other reason why it's not moving. We hardly blew the motor. I don't think that would have happened. So we must have damaged that chip there. Oh, that's the one that was hot. Ah, yeah, I did. That was the one that was hot, actually. It's the white and green wires. Okay, so whatever that was, 25 volts. I blew the motor driver rather than the chips. I wonder what's the max input voltage for one of those motor drivers. Let me just take a quick look. I take it it's below 25 volts anyway. Turns out 15 volts was the max for the motor driver. So, our max for the motor voltage on the motor driver. So we were lucky that we got up at 20 volts before anything happened. It was quite resilient then. So, well, anyway, like I said, I'm going to be changing that motor driver, that control board anyway. So I was kind of expecting something to break at some stage there. I thought I was going to blow the 3.3 volt motor driver, and it just seemed to continue on without a problem at all. But probably because it was using very, very little current. Well, I don't know what else we can take a look at here. I think that's pretty much all we can do with the little motor driver. It seemed to work really well. If you wanted to get to your 15 volts with your battery there, or well, maybe 15 volts might be pushing it, but if you got to the 14 volts, like we seen before there, as the battery voltage dropped, it was going to hold the 15 volts. So I'll show you that. I can kind of simulate that, I suppose. I'm getting confused with all my wires here. So I need this output, this input, and let's take it off for a second. We see what voltage we're actually at. And so that is at 22 volts. Then we put it back down to, we'll say 14 volts. Up this a little. Right, so there's 14 volts. Let's say you were going to use an 11.1 volt battery and you wanted a stable 14 volts. So we've it hooked up to 14 volts here. Power it up. Working fine. very little noise on our signal here. And all our controls are working fine, right? So that's from our 3.7 volt batteries, which is the same as one 11.1 volt LiPo. I think that's what they're kind of called, I suppose. But one 11.1 volt battery. And now I'll simulate your battery kind of being discharged just by removing one cell here from this. Bring us back to the 7.2. If we can. No, is that 7.2? Yeah, it would be 7.2. So we're back to 7.2, and our voltage is at 13.9 volts, and we still have very little noise. Okay, we're having trouble with the main boom motor there. It's still cutting the whole thing off, so that's not so good. But your battery's not going to discharge to 7.2 volts or whatever I'm at here, probably more closer to 8 volts. Like your 11.1 volt battery is going to be discharged long before the voltage drops that low. So for it to be fairly stable, this thing seems to be pretty good. I mean, having or if you want to maintain a stable voltage at like 14 volts, one of these little step up converter modules seems to work pretty well. But you would have to, find somewhere in here that you could nearly give it a little bit of space for the heat to dissipate, because if this thing was going the whole time, and say you had your tracks going and your boom is digging into mud the whole time, or into gravel or whatever, so you're always putting load on, you're going to be drawing like over half an amp, maybe up to an amp if you have enough motors going. And at that stage, this little thing is going to be starting to heat up. Something in it will be starting to heat up, probably the little voltage regulator itself there. I'd imagine that'll start to heat up, and all you have to dissipate your heat on this module is the back pin here. There's no heatsink or anything, so that's all going to get very hot, and when that gets hot, then your control board is going to get hot because it's all confined in the one little space, and then it's all going to start to affect your electronics. I think you'd be starting to run the risk of damaging them. But as it stands there, actually I suppose you could, there's bolts there, right? There's two little bolt holes there, so if you drill 2 holes through the bottom of this aluminium piece here, and you just bolted it in there, put maybe a little bit of heat transfer compound, like you get on a heatsink for a computer CPU. If you put some of that through, you transfer the heat to the big aluminium base of the excavator there, so that would be a huge heatsink. I'd say that'll be fine. That'll probably improve your efficiency of your little module there a lot. So I suppose in conclusion, this little module probably would be a good job for keeping an 11.1 volt battery up at a stable 14 volts until it's discharged. To go from 3.7 volts up to the 14 volts, that's not going to really work. You're going to be getting that noise that was cutting out it was actually cutting out the step up module itself for whatever reason, but you're going to get that noise, and once you get that, you're just going to be driven mad turning on and off the module or the excavator. You're either better get the 3 batteries and drive the module at 14 volts, or just drive it straight from the 3 volts or the 3 batteries. I'd probably drive it straight from the 3 batteries, or a single 11.1 volt. You don't have to do what I did where I put the batteries together. That's just, I didn't have an 11.1 volt battery, so that's what I used instead. And it's also, that's very handy when you're testing, to be able to go from 3.7 to the next voltage up to the next voltage up without having to have those 3 different capacity size batteries. Well, I think we've pretty much covered everything we can on this kind of topic, so if you have any comments, let me know below the video after. It'll be uploaded to the channel the same. Let me know if anyone's seen a notification that this was going to take place, because I have a feeling that it didn't work, even though I did set the notification 2 days ago. I think it might have set it for something else. I have to study up on my YouTube controls, I suppose. But yeah, I think that's all I have to cover in this video. Thanks for everyone who tuned in, and let me know below the saved video in the comments if you have any questions and suggestions on that. And I think that's pretty much everything. So thanks very much for watching. I'll see you in the next video.